Today I would like to share and brief some knowledge that I've gained through my classes taking in this semester. So I would like to touch on DC circuit analysis, which actually the method is based on three basic electrical principles, which is Kirchhoff current law, we make it short as KCL, and Kirchhoff voltage law, and without forgetting the basic Ohm's law, V equals to IR principle. So to analyze and to determine the values of the electrical parameters in a circuit, especially DC circuit in our case here, we take into consideration nodal and mesh analysis. Nodal, basically we deal about Kirchhoff current law, and the basic analysis of nodal constitutes the analysis using a current source, or we take consideration of the analysis with the voltage source. And not to forget the mesh analysis, we have the analysis of mesh, which constitute KVL as the principle that we use to analyze, and we use analysis with voltage source and the analysis with current source. But today my scope of stress is nodal analysis, which basically I will play around with only Kirchhoff current law, which I will talk about it in terms of KCL. Okay, so this is the first case given. As we see, we have the solution here. Okay, the case 1 is the two independent source. Okay, independent source in a circuit, we can see it's round. Okay, the two independent source of current. This is a very basic nodal analysis case that we will be attempting. Might as well we are not going to see it very frequent like this, because it's going to be more complicated than this, but we go from basic first. So at the first point, what we need to do is to set our node, to put on node. Node is very important in determining what is the target that we want. We need node to make a junction and suppress to KCL, because without a node we don't fulfill the definition of Kirchhoff current law, which denotes a boundary or a node that it goes in and goes out. So from here we can calculate the algebraic sum, and we can determine the variables that we denote in the equation. So at here, this is our first node. Okay, the first node. Okay, from here we see the 1 ampere current is going from here, and it goes inside of the node. So we put it as 1 at the side here, okay, on the left, because it doesn't have any similar or common direction friend going to it. So we have I6 ohm. We can't put V6 ohm because I here we are taking V over R, because this is the resistance value. We want to know the value of voltage, so we take I as the variable. So I6 ohm equals to V1 here over 6. So this is an example how we write the expression of the I in the nodal analysis circuit solving. So here, this is how it goes. I6 ohm goes out and I2 ohm goes out. So we put it as adding here. Okay, so this is I2 ohm, which is V1, okay, minus 0 because it goes to the ground, and over the resistance value. Mind that how we determine it as the voltage of high to the low voltage region. So this is how we write it. So V1 is the higher one. After it goes to resistor, it has a voltage drop and all. So it goes here, and this is the lowest point from the V1 that passes through I2 ohm from the resistor that passes this 2 ohm resistor, so it goes to the ground here. Okay, so this is how we write it, V1 minus V2 over 6. So we break it to a normal basic mathematical calculation. Actually, this is only what we are learning. This is our mathematical application. Okay, because we just compute it using our basic mathematics skills. So we got the basic first equation, which is 2 over 3 V1 minus 1 over 2 1 over 6 V2 equals to 1. From here we simplify and we get this. And note 2, we see note 2, the I from 6 ohm going towards the node, and the I of 7 ohm and the current going to 4 ampere, so it goes out. Okay, so I6 ohm is only on the left because it goes in, and I7 ohm goes out, plus 4. We don't write ampere there, we just write 4 as the equation variable. So V1 minus V2 over 6, because high resistor, low pace over the resistance value, so we got this. And V2 minus 0 over 7, because it doesn't go anywhere else except for the ground, plus 4. So this is how we compute it. 1 over 6, we just make a mathematical operation here. We push 1 over 6, 1 over 7 V2 here, and we make the only integer, which is 4 there. So we perform a mathematical operation and we got this. So now I have these two equations, and we have to use this calculator. Okay, to do it, we just press mode, and we got this. Okay, we press 5. Okay, so now we have 1, 2, 3, 4. 3 and 4 let it go, because we are dealing with quadratic, so we don't using quadratic. In node analysis, we don't touch on quadratic, we just touch on linear equation. So we are using 1 as the mode we are using, because we are just dealing with 2 nodes, which is 2 equations. If we choose the second one, means we have to have 3 nodes, then only we can use the second equation mode. So now we just substitute. A denotes the coefficient for V1, B denotes the coefficient for V2, and C denotes the integer on the right side of the equation. So 2 over 3. Okay, B is negative 1 over 6, plus we don't have anything, just we put 1 here. Okay, equals. Okay, here we continue with note 2. So 1 over 6. Okay, so negative 13 over 42. And 4. So finally we got V1, which is X, equals to negative 2 volt, and V2 equals to negative 14 volt. So which means the voltage goes from the opposite direction. It behaves oppositely, not following towards the nature of the circuit itself. So we are done for case 1. Okay, this is case 2. So case 2 is independent current source with one unknown. The unknown is Ix. Okay, so in this case we got node 1, node 2, node 3, because there are 3 junction of separation of current. So okay, now we see by putting here, we denote as node 1, and the voltage here we denote as V1 for node 2 V2 and node 3 V3. So 10 goes in and I3 ohm goes out, same goes to I2 ohm. So we write it as 10, okay, equals to, these 2 goes out, means it plus I2 ohm plus I3 ohm. So this goes in and this goes into V3. So the highest minus the low voltage region, so V1 minus V3 over 2. So this is for I2 ohm, minus the resistance value 2. So we got I2 ohm, I3 ohm, V1 minus V2 over 3. So we got the electrical equation here, so we proceed to the mathematical and we break it here. We just perform mathematical operation for the common V that is here. So we got this. Okay, so this is how we got for our first equation, and this is node 2. Okay, node 2, we look at here, node 2. From here we see that Ix, okay, is the I that passes through 4 ohm resistor. So it doesn't pass through any other resistor else except for I 4 ohm. It's the 4 ohm resistor. So we can say that Ix is just the same as I 4 ohm. Okay, because it doesn't pass through any, because you can't see it acts at any resistor. So Ix equals to I 4 ohm, and I 3 ohm for the node 3 goes into the node, and 4Ix also goes in, and Ix only goes out. So at here, since these two goes in, so we add those two. So I 3 ohm plus 4Ix equals to Ix, because Ix is the only opposite direction going. So since this Ix is in common, we can just push it here, and actually it obeys the Kirchhoff law, because the algebraic sum will let it make a 0 here. Okay, 0 here, since we perform and we get a 0 here. So I 3 ohm plus 4Ix minus Ix, so we simplify, we get this. Okay, from this 4 minus 1, 3. So I 3 ohm V1 minus V2 over 3, the resistance value, and 3 V2 over 4, because V2 over 4. Okay, V2 minus 0 over 4. So we simplify V2 over 4, and this we perform the normal mathematical. Okay, what negative 1 over 3 plus 3 over 4 will give rise to positive 5 over 12, and this stay, and a 0 here. This is our second equation. And node 3, the final node, we got it as this. So node 3, look it here, I 2 ohm goes in and others goes out. So 4Ix goes out and I 6 ohm goes out from the node. It goes out from the node. So I 2 ohm here on the left, so 4Ix plus I6X, because it's the same as we apply from here. So 4Ix is also equals to 4V2 over 4, because it's equals to equals to I 4 ohm. So I 2 ohm V1 over minus V3 over 2, V1 minus V3 over the resistance value, and this is the same as this, and I 6 ohm, look at here, V3 minus 0 going to the ground over 6 here. So we make it simpler here. This is the part of mathematical equation that we must perform. But, it's easier for you to let it make all the variable on the left or either on the right, because it might make you complicate when you are computing, because we are dealing with V and the difference is just 1, 2, 3, and we might got any confusion going on. So as we perform, we finalize, we get this for node 3 equation. And for here, we need to use the calculator. Okay, goes to this equation. Now we are dealing with 3 equations, so we put 2, and this gives rise to this. We copy back 5 over 6 V1 equation, press equal, negative 1 over 3 equal negative 1 over 2 and 10. So second equation, 1 over 3, 5 over 12. C we don't have, as if V3, so we put 0 and another 0. Third equation, 1 over 2, negative 1, negative 2 over 3 equals to 0. So we got the same answer as how it is written. So X denotes V1 80, Y V2 negative 64, V3 156 as Z. So since Ix equals to V2 over 4, as we know V2 is negative 64 and it acts opposed to the voltage of the current source movement. So V2 over 4 is Ix. So it equals to negative 64 over 4 equals to negative 16 volt. So Ix equals to negative 16 volt. So this is the solution for case 2 nodal analysis, which we deal with independent current source with one unknown, which is the unknown is Ix. Okay. Okay, so now we go to the case 3, which is more complicated, so we do it together. Okay, so here we have a dependent current source. Okay, this is the dependent current source which we never deal before. Okay, so the same, all these are just the same. Okay, we take node 1 first. Okay, we put node 1 here. This is node 2 and node 3. So node 1 is V1. We just variable it as V1, V2, V3. Okay, so this is the equation for node 1. Y3 because 3 goes in and others goes out. So Ix and I4 ohm goes out. To determine Ix, we know that Ix is the imaginary that pass through 2 ohm resistor and stops by at V2. Okay, so this is Ix. So Ix is also, we can just say Ix is equals to I2 ohm. Okay, so Ix, we just put it as I2 ohm. So I2 ohm equals to V1 minus V2 because the lower, and over 2 plus V1 minus V3 over 4, which is I4 ohm equation, V1 V3 over 4. So we got this equation. So this equation equals to 3. So the final one, after we make it a mathematical operation, we got 3 over 4, 1 over 2 V2, just copy back 1 over 4 V3 equals to 3. First equation. Note 2 equation. Okay, note 2. Note 2, we see I2 ohm goes in. Okay, I2 ohm goes in, others all goes out, which is I8 ohm and I4 ohm. So we copy back I2 ohm on the left because it goes in, I8 ohm plus I4 ohm. Okay, I2 ohm, as we know, V1 minus 2 over 2. I mean V1 minus V2 over 2. Okay, so I8 ohm equals to V2 over minus V3 over 8 plus I4 ohm V1 minus V3 over 4. So this, what can we do is we put all the thing on the right side. I mean, I make it safe on the right side because it says the same, left or right it says the same, but you must make all the variables either on left or right. Okay, so we broke it down and we get this as the big equation. So we simplify it as 1 over 2 V1 plus 1 over 8 plus 1 over 4 plus 1 over 2 V2 minus 1 over 3, 1 over 8 V3 equals to 1 over 2. Okay, don't forget we put V1 at the left, so we compute it as over here, negative plus negative 1 over 2 plus 1 over 4. Okay, so this is our equation. So here is our negative value V1. We compute it, we will get 7 over 8 V2 minus 1 over 8 V3. Okay, so this is the equation we got. So this is second equation. Okay, so our node 3, okay, equals to I8 ohm, because I8 ohm is the only one goes in, and I4 ohm. So I8 ohm plus I4 ohm equals to 2Ix, which is equals to I2 ohm. So I8 ohm V2 over V3 over 8 plus, okay, make it like this. Okay, so I4 ohm equals to V1 minus V3 over 4. 2Ix equals to I2 ohm, which is also equals to V1 minus V2 over 2. Okay, so we cut this and this, and finally if we arrange everything back, we'll get V1 minus V2 minus 1 over 8 V2 plus 1 over 8 V3 minus 1 over 4 V1, and not to forget the final one is 1 over 4 V3. Okay, so by simplification we got 0 equals to 3 over 4 V1 minus 9 over 8 V2 plus 3 over 8 V3. So we use calculator. Okay, equation 2. Okay, so we substitute all the value, 3 over 4. A denotes the coefficient of V1. Mind that all the negative value should be put also. Okay, equals to 3, and we got the equation of negative 1 over 2 equals to 7 over 8 equals to negative 1 over 8 equals to 0, and then note 3 equation, 3 over 4 minus 9 over 8 plus 3 over 8 equals to 0. So okay, this is what we got. Okay, so our V1 is equals to 4 over 8 volt. V2 is equals to 2.4 volt, and V3 is equals to negative 2.4, which means it acts opposing the motion of the circuit. So since we know I2 ohm, which is also equals to Ix, is equals to V1 minus V2 over 2. So V1 is equals to 4.8 minus 2.4 over 2. So we got it as 1.2 volt. So the voltage that passing through I2 ohm, which is imaginarily called Ix, is equals to 1.2 volt. So the V that passes through is 1.2 volt. So that's it, and that is the nodal analysis cases that we discussed today. Thank you.